Welcome to the ARC Forum. This session is on operator training effectiveness. We have some very talented panelists here. We probably are well represented in the oil and gas industry in this particular session. The first thing I'd like to mention is that one of the things at least I do at ARC is a study on operator training and immersive training simulations. And so I've kind of looked around that marketplace and seen what's happened. So we'll talk a little bit about some of the trends in that industry. One of the ways that OTS systems or training systems get justified is it protects assets. And the number one asset it protects is the people that are running the plant and the people that are living near the plant, all right? That is usually the first most important asset to protect. And of course, there's the physical asset of the plant itself. Once safety is generally dealt with in an adequate way, a slightly lesser priority is always things like quality, yield, efficiency, the business interests of the plant have to be satisfied. Obviously, we've seen some trends to make those simulations lower cost. There's a lot of advances in technology that have made simulations easier to deploy, more effective, and our panelists will, our speakers will address that issue. We have done some recent surveys on operator effectiveness. What does make an operator effective in doing his job? And I'll present a little bit of that briefly. So we have Brent Kadzierski, all right? He's from the Shell organization on simulation-based training. We also have Larry Staub. He's coming from Kinder Morgan, a pipeline company, and has a very interesting story about how to train at multiple facilities simultaneously. And finally, we have David Lafferty. All right, David has a lot of experience in also in the oil industry, and will be presenting more on the virtualization issues and definitions, basically, to help clarify some of the new technologies coming out in that area. And we also have Graham Provost as our panelist. So I already have some questions for him. He is a senior consultant with Schneider Electric and has quite an extensive background in nuclear submarines and nuclear training of pilots and things like this. So we always look to some of those aircraft and pilot training systems as sometimes role models for oil and gas or industrial training. So roughly the total market size for OTS, ITS, at least in the surveys that we have done, is in the range of $600 million. And as I mentioned, safety is a big issue. And one of the issues that always comes up is how do you justify it? And did you spend enough money? Did you do an adequate job at training? And actually, one of the things I want to work on at ARC is whether or not we're spending enough money, whether or not we're doing enough attention to that. And one of the statistics that I like to look at is, if you look at the 10 worst industrial accidents, most expensive industrial accidents of all time, you find some huge costs associated with the liability. Chernobyl, $600–700 billion alone. So when you look at those post-accident reports, operator training is one of the key things that might have prevented that accident. Well, if you have $600 billion of losses, and never mind Fukushima, never mind the Texas City and the Gulf of Mexico and the Exxon Valdez, and operator training might have saved a significant percentage of that. Well, a significant percentage of $600 billion dwarfs $600 million marketplace. There's some evidence that we're not spending enough time and effort on that effort, and also safety shutdowns. Control systems have become virtual. We can execute those. We can connect those to simulators on all kinds of virtual platforms, cloud servers. That has definitely helped to make things better. High fidelity first principle models. We still have some issues there. They don't just come by themselves. To get high fidelity is a costly effort. And we always say that all models are wrong, some are useful, all right? End users are seeing those baby boomers retiring left and right. I've talked to several people. I'm retiring in May, all right? These guys are very talented guys, have 20, 30 years experience. You're not going to take somebody right out of school and put them on the shutdown system on a nuclear plant or tuning up a compressor anti-surge controller. Let me see here. I think that blocks, all right. Let me see if we're going forward, are we? Am I losing my net? Can you just navigate that for me? One forward, all right? There's a lot of technology with 3D modeling as well. Last year in this time, I asked anybody knew how old Homer Simpson was, all right? And it was kind of an interesting thing because it turns out Homer Simpson was 65 last year. That means this year he was retired. And we took a vote, who will replace him, Bart or Lisa? All right, well, who do you think won, all right? So right now, running this plant for the last year, it was not Bart. He didn't get the job there. I think he's a welder or something, down at the local, bike shop or something. And but Lisa, she's running this plant for the last year. So we had to train her. She's been in a training program for the last year. And just thought that you would be interested to see that. One of the other things we point out is that in terms of the effectiveness of training, simulation is an enormously effective training mechanism. In fact, if you look back at all of the simulations you use, I don't care, girls, boys, whatever, dollhouses, pictures, sculptures, so many things are really simulations of reality. We have used models and simulations to learn almost everything we learn. Training, so modeling and simulations are fundamental to learning. And, there are some models might need to be accurate, all right? So sometimes we learn the wrong things if we look at the wrong models. I'm not going to go through all of these because I want to keep us moving, all right? So what information? In a study that we did for a major oil and gas company, some of the conclusions were operators are most effective when they have a lot of information about the process they're running. Accurate information from sensitive instruments, temperature, pressure, level, flow stuff. It's important that they know the state of the equipment that's running, which stuff is in service and not. Some people said all of the above. A lot of people said maintenance. One of the other, accidents happened in maintenance activities, so it's very important to know who's got, who's been in the maintenance sign out, what's going on for maintenance in your unit. So these were some of the answers to some of the questions, but keep in mind that control system and the user interface of that control system is the right-hand man to those operators.